Hello, everyone, and thank you for joining this webinar, The Role of a Logical Architecture in Modern Data and Analytics. In this session, we will reflect on the findings from the recent BARC report, The Future of Data Architecture, with one of its authors, Jacqueline Bloemen, Senior Analyst at BARC, who's joined us for today's session. Jacqueline will provide us with further insights, both from the global survey that led to the conclusions presented in the report. We will also look into how implementing a logical data fabric powered by data virtualization helps organizations extend the life of their data warehouse implementations while embracing the need to manage and eliminate data silos. So like I mentioned, our speakers today are Jacqueline Bloemen, Senior Analyst of Data and Analytics at BARC, and Inessa Gerber, Director of Product Management at Denodo. Finally, I want to mention some quick notes about the webinar. You will be in listen-only mode, but I encourage you to submit questions throughout the presentation, as we will pause after each speaker has finished their part to give you an opportunity to ask them your questions and doubts. Okay, so without further ado, I will turn it over to our first speaker to begin. Thank you very much. Jacqueline?
Thank you very much, Susanna. Welcome, everyone, to today's webinar. And my thanks also goes to Denodo for inviting me to participate in the discussion today. I want to report about or tell you something about our latest survey, The Future of Data Architecture Has the Data Warehouse Had Its Day. My name is Jacqueline Bloemen, as we've heard, and I've been working in the IT and data industry for a number of decades. So our survey was a global survey with over 250 participants. We had a wide coverage of industries and also of company sizes. We had about roughly a third each of small enterprises, medium-sized, and large enterprises. So, I mean, when you want to speak about architecture, of course, architecture wants to follow the requirements that are there, right? That's what makes sense, at least. So one of the first questions we posted was, what challenges do data users actually face? And the top one of the list is actually business users cannot implement new requirements themselves. And I'm sure that sounds familiar to you. And it kind of rings the bell of self-service. But one thing I think is also rather striking is that the one lowest rated on the list, with only 24%, is that the tools are too technical. So apparently the tools themselves aren't not really the problem. But let's look a little bit on. So many equate data democracy, which is a buzzword, to self-service analytics for business users. Now, what do we do when we provide self-service analytics? It's basically and mainly geared towards reports, dashboards, and classic analysis on the data warehouse or data lakehouse, whatever kind of architecture you have, but on the single point of truth that has been built for a while to ensure that, that business users get high quality governed data. And indeed, our study participants reported that, or 74% of them reported that they are introducing, they have either already implemented or plan to introduce analytics tools suitable for business users. And a slightly less percentage are actually giving business users more freedom in the use of data and analytics. So probably maybe giving the possibility of uploading some individual data, something that they couldn't have done before, for example. Now the numbers are slightly higher for best in class, for the peer group best in class. So they are actually even more active in this area. But self-service, or the needs for having flexible analysis, is actually not just limited to the data warehouse from a business perspective. There is also the need to do embedded and real-time analytics directly in the operational systems. Although we also see here that the self-service tools that are being deployed on the data warehouse are frequently also being used in this area. On the other hand, there's a need for data discovery onto advanced analytics, not only for data scientists, but also for what is frequently called the citizen data scientists in the business areas. And these tasks usually need additional data that is not found in the data warehouse. And this data has to be prepared. For example, I might need to calculate some features that I want to use in my AI model. And so for this task, you would probably need data preparation. But interestingly, comparing to the basic analytic tools that are being provided, only 48% of our study participants are actually introducing data preparation tools suitable for business users. Now, here again, the percentage for best in class is much higher. So the problem here is that if you don't provide data preparation tools to the business users, if they have a need to do data preparation for data discovery, which is frequently the case, they are forced to use some other solution that somehow supports them in data preparation, and that could possibly be Microsoft Excel, which we see very often. And while it's understandable that you don't want to put data preparation into the hands of every user out there because, of course, of fear for loss of data governance and data quality, on the other hand, it's not really good for data governance and data quality if you're forcing business users to do their data preparation with Excel. So let's move on. What other challenges do we see here? And indeed, data for analysis must be tediously gathered from various sources. So that really seems to be an issue in everyday work. And while all agree to this, and with 43%, the agreement in the line of business is even much higher. So they are really, really, really affected by this challenge. So let's take a look once again of what we're doing when we're providing self-service to the business users. As I mentioned before, it's very much focused on the data warehouse or the data lakehouse or whatever your qualified database is called. And the problem around this is that 43% of business experts say that the problem here is data warehouses, data lake, or whatever does not really cover our requirements. It might have part of what we need, but often enough, it's only part, and we have to add additional data to do our analysis. And even 70% of business experts say existing data is not suitable for the necessary analysis, regardless of the data warehouse. So overall, the data we find and that we have to use, it's not really suitable, and we have to work on it to make it suited for the questions we have. So obviously, yes, there is a need for data preparation even beyond data discovery, and rather for everyday reporting and dashboarding as well. This is actually a serious issue. So let's move on to the next point here, the next challenge. Now, it might be, a very easy solution to the problem to say, oh, why can't the central data and analytics team just pick up speed and integrate more data into the warehouse or lakehouse faster? But the problem here is they just cannot. They can't react quickly enough to new requirements. So let's take a look why that might be. Perhaps it's in the way we're organized. And if we look at traditional software development or software customization, if we're speaking about standard software, we always actually have domain-oriented cross-functional teams. So we have business people, we have development people, and we have people from operation working on an application that is from a specific domain, and they collaborate to get this thing up and running. And the good thing about it is that these people are focused on a certain domain. So they're focused on a certain business part, a certain part of the business. And for another part of the business, we have another team. Now, with data and analytics, traditionally, we have always worked with pure functional teams. We have one data and analytics team that is expert on data engineering, data architecture, and developing reports and dashboards, etc. But they do not have specific domain expertise. Rather, they work for all domains in the enterprise, which of course means they have to work for many more people than the development teams for the domain-oriented applications have to work for. So their workload is much larger, and the team size is often enough even smaller. So the challenge here is absolutely limited scalability, but also limited business domain expertise. Data and analytics teams always have excellent data engineers and excellent data architects, but they're obviously not business experts. And that is really a problem here. And 73% of business users agree to this assessment. And there's a risk to this limited domain expertise, as we see here, because 70% of business users also say implemented data and analytics applications do not cover our requirements. So we're not only doing less than we need to do, and we can't scale, but we're also not doing it good enough to actually meet the needs that the business has. So what would be the concepts and technologies that the companies find will be important to improve this landscape in the future? And the top on the list is actually improving data sources and or their interfaces. And here the hope is, if I improve the source data in the first place, I'll have less work to do when I provision the data for analytics. And overall, 48% agree, but also 45% of business experts agree here. The next point is making all relevant data sources searchable and accessible. So that addresses the point of tediously needing to gather data from all sorts of sources without actually having support in doing that. So just having let's say a portal to all enterprise data, first just to search in it and then be able to receive access to it and link it together for my analysis. And here it's very obvious that it's a very pressing issue for business experts, because they agree with 55%. And one approach that could actually help make this happen is data virtualization, which is the third one on the list. And again, the agreement in business is even higher than on overall average. Interestingly, now both concepts, making all relevant data sources searchable and accessible, and data virtualization as a supporting mechanism, they both need metadata. They both need semantic data to actually build this bridge across various data sources. And interestingly enough, the respondents actually using these concepts, or seeing these concepts as important for the future, are very few. Only 17% are thinking about an overarching semantic data layer, and only 28% are actually thinking about introducing a data catalog and or a metadata management approach. So here, there's really still a lot to do and a lot to learn. Now let's get back to the business-related measures, and we already spoke about the top two. Here we have the top 3 to 5. Additionally on the list, so harmonizing master and reference data is a very important topic, which is quite obvious. Master and reference data is one of the most essential things to be able to actually link different data sources together. And if this master and reference data isn't harmonized, then you're going to struggle very much with it. Providing the understandable documentation for data ties into the fact that I want to search in all data that is relevant to me in the enterprise. But it actually also requires that business people help write this documentation, because otherwise it's not understandable for other business users. And then the point, establishing responsibility for data consumption, but also for data production in the business domains, which would address the problem of not enough business domain knowledge in the central teams. All these 3 points are very important to many. So those that find these of little or no relevance are all under 10%. But what I think is very interesting here is that while the self-service analytics measures that are top of the list, and that most enterprises are actually active in. Here, the number of enterprises that find these measures relevant but have not planned any activity here, these percentages are rather high. So we know what to do, but somehow we can't get started on some of the most important things that we should do. So there are concepts out in the marketplace, buzzwords that describe some of the things we actually want to do here. One would be data intelligence. Data intelligence is intelligence on data, not intelligence from data, such as business intelligence described. So that's providing the mechanisms to share knowledge to users so that they win intelligence about the data that is available to them. And on the other hand, concerning responsibility for data in the business domains, one of the hottest trends currently being discussed is data mesh. And data mesh, now we can't dig into exactly what data mesh is today, but it's basically data product ownership in the business, so decentralized data product ownership. And there is also discussion around data mesh on architecture. And I actually know a lot of customers that are planning to implement or build their data mesh on a data lakehouse. Now, does that make sense? Well, it sure can. If you're building a data lakehouse, a modern data lakehouse with modern technologies, then it's certainly something you could implement a data mesh on. And I've seen customers where that's working quite well. But there's a but to that as well. Because when you start building your data lakehouse, it'll take quite a while before there is a significant number of sources integrated into this environment. And in the meanwhile, your business users will still be working with the legacy data warehouses, or even specific data warehouses that will still be there, even though the data lakehouse has become quite mature, say, for example, SAP BW or other specific data warehouses. Then you might have departmental analytical apps that have been created in the last years based on tools such as Tableau or Qlik. You might also have an IoT platform that contains very valuable data you will want to analyze. Or you might have operational analytical apps where KPIs are defined that you also want to integrate in the rest of your analysis. So your data lakehouse alone will not be able to cover all the needs that your business users have, because data lakehouse is a central concept, and by being that in itself, it has some limitations. Now, that doesn't say you should not build a data lakehouse. A data lakehouse makes sense for a number of use cases, but what should be seen is that a data lakehouse alone is not enough. And this is where another concept comes to play, namely the concept of the data fabric. Now, in previous years, there has been a lot of discussion around the logical data warehouse, which was basically a concept of data virtualization for the data warehouse, but it was traditionally very much focused on serving ad hoc queries across distributed sources. But a data fabric has that inside, because it's one of the concepts that are very valuable, but it has other concepts of data virtualization as well. And as such, distributed data pipelines, because you want to be capable of orchestrating data pipelines across various data sources as well. Data fabric does not say you have zero data movement. You will always have data movement, but you want to have flexible capabilities for when you want this data movement to take place, and you want to be able to change them behind the covers if there's a performance issue or something like that, so that the business users don't even realize something has changed. So that's the concept of a data fabric, breaking down data silos based on metadata-infused data virtualization in distributed data pipelines. So wrap up, I think for the future, while certain central and physically focused data concepts are still viable, I think we have to add logical data concepts to these when shaping the future of the landscape, then being mainly data intelligence, data fabric, and data mesh. I'm looking forward to your questions.
Thank you, Jacqueline. Thanks very much for your presentation. Really great insights and very clear. So now, as Jacqueline mentioned, we're going to dedicate some time to answer some of the questions that have come in while Jacqueline was presenting. But just to let you know, feel free to keep submitting any questions that you might have now and throughout the rest of the presentation, because we'll have another stop for Q&A at the end. Okay. So let's go with the first one, and that is adoption of data virtualization in the market picking up? And it's a two-part one. So what are common barriers to adoption?
Yeah, great question. Thanks. So yes, definitely. The adoption is definitely picking up. I think when we engage with customers on the topic of their future data landscape and architecture, I think with 9 from 10 customers, they have data virtualization on their list. So that's the good news. But the common barriers, I think, to adoption are unrealistic expectations and or fears. So we sometimes hear that customers have the expectation that data virtualization will solve everything. We can use it as the central access layer for everything. And that's not true, because we have such a wide variation of use cases in different environments. For example, pulling an ad hoc analysis for an ad hoc information need is something totally different than using a certain KPI in an operational process to help someone make a certain decision. And depending on the pattern of your use case, data virtualization will be a good answer, or it will be a not so good answer. So you basically have to structure your different use case types and test them against what are the capabilities of data virtualization, but also, of course, what are the limits? Because every technology also has limits. And then on the other tone, fears of data virtualization are commonly, oh, that will never perform. That's just my data is too difficult. I can't join it together in a data virtualization tool. It's too complex. Or I have to have some transformation logic, and data virtualization just can't do that. But I think that the message here should be data virtualization is a very mature technology. It has been in the marketplace actually since decades. And solutions in support of data virtualization have quite a lot of features and functions inside to address exactly these fears. So there again, don't expect too much, but don't expect too little, because these solutions are really mature.
Thank you. Perfect. So we've got another one. Hello, Jacqueline. Thank you for your explanation. On slide 11, you mentioned data virtualization can actually work as a potential solution to searchable and accessible data sources. Could you please talk a little bit more about that topic?
Yes. Oh, yes, definitely. Data virtualization is a way to build a layer over various physically disparate data sources. You can link them together and build semantics on top of it. So it could be the entry point for people to search for data, regardless of where it lies. And it could be just that. For example, in terms of perhaps fear that data virtualization would not deliver the performance you need to actually post a query against it, which maybe in some cases could be. But I mean, just for searching data, just for finding data sources and looking at an example of the data and joining this example perhaps with other data, data virtualization is really a quick start to get this up and going. As a layer, perhaps underneath a third-party catalog, or just using the data catalog that the data virtualization solution is shipped with. So that's really a really good enabler for getting a quick start to this job.
Okay, thank you. So there's actually quite a few more questions that came in, but I do want to give and make sure Inessa has enough time for her part. So I think what we're going to do is let's continue with the presentation, let Inessa do her part, and then we'll have some extra time for Q&A at the end. Okay, so Inessa, I'm handing it over to you.
All right, thank you. And thank you, Jacqueline, for the wonderful presentation. And I promise you, we will leave sufficient time at the end for all the Q&A. And I would like to continue on the same topic of data fabric and how is data virtualization enabling the creation of a data fabric. So first, let's talk about the key concept. As you saw in the Jacqueline's presentation, it's all about the business user. We need to empower the business user with the right information. We need to guide them to make data-driven decisions. The only way they can do that is if we give them access to the right data, not just any data, but curated right data. And we also need to ensure that we can create this democracy of data, so we can actually expose the information while still ensuring governance and compliance across our organization. Because you don't want to expose information which the user should not have access to. And also, and I think this is the big part, is that as you are solving for your use cases today, you have to ensure that you create a flexible architecture for the future, because your use cases are going to change tomorrow and in 5 years from now. So as those requirements evolve, you need to ensure that your architecture pattern is flexible and adjustable to new requirements. So let's take a look at the cloud. And everyone is moving into the cloud. And I think this is a wonderful approach to simplify the ecosystem of the enterprise. But one of the biggest misconceptions I still get from clients is that, well, I'm going to move all of my data into the cloud environment and everything is going to be centralized. Well, that's not the case, because if you look into any cloud environment, you are going to see that your data is still going to be distributed, because you are going to have different types of repositories in the cloud. So the fact that you moved into the cloud does not mean that you centralized your data assets. And on top of that, in the reality, most clients are still going to find themselves in a hybrid architecture where some of the data is going to be in the cloud, while other data is going to remain on-prem. Or maybe you also want to have access to external partner data or social data, the data which you may not own. So what this means in reality is that we gotta embrace this distributed data landscape. It's going to continue to be distributed, no matter if you're in the cloud, multi-cloud environment, because of different regions and different compliance requirements. Having legacy data sources. We still have mainframe data sources. We still have many file-based data sources. And also, again, we're going to continue introducing new technologies simply because, at least from my experience, IT is very quick on adopting latest and greatest repository to store the information, while the business users are much slower adopting new techniques. And with that, the only way we can ensure that both teams are in alignment is by embracing a logical approach, by embracing the data fabric, saying that, you know what, we're going to enable the IT to continue doing whatever they wish to do, embrace the new technologies, move the data as you wish, while we're going to enable the users, the business users, to continue using the tools of their liking, the tools they're used to use, and we're still going to provide this logical layer driven by the semantics, enforcing the security and governance, while still exposing relevant information to the business consumers. So since we are talking about data virtualization, what is data virtualization and what is Denodo? Well, data virtualization is an engine within the Denodo platform. But as Jacqueline has mentioned, data virtualization is not the only component which is required for the data fabric implementation as well. And there are going to be many technologies in a data fabric. If we look at the Denodo as the one data logical platform, in the Denodo, we have to talk about integration, how we can integrate across multiple diverse ecosystems, be that in your lakehouse, be that in your file systems, or across the traditional data sources. Ability to connect and virtualize the information from multiple data sources is critical. But on top of that, we need the ability to manage everything. So we need the ability to use AI-driven recommendations to guide our users to the correct data sets. We also need to use AI recommendations to ensure that we can link correct data together. We need to provide a governance and security layer on top of that. And we need to ensure that we can deploy solution in any environment, be it on-prem, cloud, multi-cloud, container-based, in any environment. And we should be able to manage all of that centrally. And for the business users, for the data scientists, we need to be able to deliver the data. And as mentioned before, having a data catalog, and Denodo provides a data catalog, to make data searchable and accessible is going to simplify the data discovery, not only for the business user, but also for the data scientist, where the data scientists usually spend a large percentage of their time doing data prep. If you reduce the data prep effort, you can enable your data scientists to concentrate on what they're supposed to be doing, generating insight, generating models. So exposing data to any consumer in any shape and form they would like the data to be delivered is critical for data virtualization. So looking a little bit at the architecture, and this looks very similar to the data fabric approach. You have your sources at the bottom layer. They can be anywhere on-prem, hybrid, multi-cloud. And then you have your different consumers using any tools of their liking, be that for the data scientist, a Jupyter notebook, or maybe a business user using Tableau or Click, or maybe another application which would like to receive data using an API, using JSON format. All of those consumers are connecting to the logical data layer, and the logical data layer, being Denodo, is connecting to the data sources. So as you can see here, Denodo is this middle layer. It stores only the metadata. It does not store the actual data. So using that metadata, we create virtual databases, which are very similar in concept to transitional databases. They have tables, views, store procedures. Their interaction can be graphical for most users, or they can be SQL-like. And it also creates this orchestrator where you can create the semantics layer on top of that and the delivery pipelines, how the data should be delivered. And it also provides the centralized governance layer for all of your security needs. Why is this important? Well, if you have users coming in from different applications, connecting to different data sources, you have few choices. You can implement your policies either at the consumption layer or at the source layer or in both locations. But if anything changes, you have to maintain it in multiple parts. If you centralize the governance and the access controls in this logical model, if you need to implement change, you do it centrally, and it takes into account all of your consumers and all of your data sources. One key aspect I would like to mention is that, as Jacqueline mentioned as well, when we are talking about the data fabric, we are not saying that data movement disappears. Data movement still exists and is still relevant for many of the use cases. And interestingly enough, Denodo, being a data virtualization platform, working only with metadata, for those use cases, still supports data movement. So you can use data virtualization platform for data movement use cases, so you can actually create your ETL, ELT pipelines. It's all about flexibility, and as I mentioned before, creating a flexible architecture for the future is going to ensure that you can adapt new technologies 2 years from now, 5 years from now, and then you can easily onboard and implement new business requirements. So we also mentioned data mesh. So what is the data mesh? I'm going to give you two architecture approaches for the data mesh. There are many more. I'm just going to give you a couple of the examples here. So let's assume you create this data fabric and you're going to use a single Denodo instance, a single data virtualization platform. What you can do is you can actually create domain-specific logical units within that platform. They're going to be owned by each department, by each logical business unit, let's say sales, customer, event management. Each one of them is going to connect to their own data or maybe share data. They're going to build semantics models on top of that, creating data products. So what's happening in a data mesh, the whole concept is that you create data products which you can share with other domains. So you have highly reusable and consumable data products containing relevant information. But this approach also gives the ownership and the responsibility of the data to the business users who have expertise on that business instead of offloading it to the IT department and losing those business expertise. So also the products can be shared. You may still want to have a centralized team which is going to provide guidance on how the information is being shared. but they're not truly enforcing it, they're just a human factor. You have corporate policies which are going to provide guidance on how the data should be interchanged between different domains. And then that information is going to be exposed to different external consumers within or even outside of your organization based on those guidelines. Another approach would be, well, you know what? Since data mesh is truly distributed, let's take the same approach as data virtualization. We're going to give a data virtualization instance to each of the business units to manage and have complete ownership. So they're going to be fully responsible for their specific business unit. The approach is similar. They're going to connect to their data, they're going to create their data models. They're still able to share the data between each other, they're able to share the data products. But instead of having just a team for the centralized governance, what we're going to do in this case is we're actually going to put another data virtualization layer on top of that as the centrally managed approach where each of the domain experts, each of the data products are going to be shared to the centralized data fabric. That centralized layer is going to enforce and ensure the governance and access controls across all of the domains. It also is capable of creating additional data products from multiple other data products, but this becomes the enforcement to ensure that you're following the corporate policies. So you take decentralized data mesh and you logically centralize it only at the final layer where you expose information externally. Let me take the next 5 minutes to take you quickly through four customer use cases. You can obviously access them online as well. One of the interesting use cases is actually from the energy, where the concept was and the goal for the project was to move into the cloud. The problem was that the cloud environment was geographically distributed, and also the migration to the cloud was very time consuming. It had to be done in stages. So they did not want their consumers to know that the migration is happening. They wanted their consumers asking for customer data to continue getting the information they're looking for. So what they did is they actually took the Denodo, they deployed it in the Azure ecosystem, they connected it to their cloud data sources and actually on-prem data as well. And they used the Denodo as the centralized logical layer to expose information to the consumers. So as they were moving data into the cloud, consumers did not need to change anything on their part. So as they continue using the Tableau, Spotfire, or any of the other tools, they continue using their tools connecting to Denodo, and the shift in data is being managed in the Denodo itself. And in their case, actually, Denodo was also doing data movement. Another use case is very similar, is actually from the insurance company Assurant. They had challenges because they were also moving into the cloud, but they could not move all of the data into the cloud. There were some regulation constraints. So they had to keep data distributed, and this is another big point. Data is going to remain distributed, so you need to solve for that use case. So what they did is they actually said, you know what? Instead of having a single Denodo instance connecting to all of my data, we're going to deploy two Denodo instances in a hybrid mode, one on-prem, one in the cloud, connecting to a local data system. And as you can see here, it's a little bit more data science oriented based on the data sources. And we're going to expose the data to the consumers. As you can see here in the architecture diagram, the data is being exposed from the Denodo on-prem directly to some consumers, while the same data from the Denodo on-prem is being shared to the Denodo instance in the cloud and then being exposed to the consumers. So this enables them to implement different policies on top of different data assets and have fine-grained controls on how the data is going to be exposed. Another use case is all driven by semantics. As Jacqueline mentioned, we gotta talk about the semantics. We gotta talk about metadata. So this is for the wealth management, and their biggest problem was that the trust of the data. How do you ensure that when someone is asking for the customer or client information, they're going to get the information they're looking for? Here's an example. I'm a credit card customer. I cancel my credit card. Am I still a client for the company? Well, for the promotions, I may be the client. For the different department, I may not be a client, but you want to ensure that you have a centralized definition of what does it mean to be a client, a customer, a supplier, a patient, a payer, or any other entity. This is where you have the domain expertise. So having this semantics layer built in the Denodo enable them to create those virtual data marts, those virtual definitions of the data models, and expose it to their consumers. So when the consumers are asking for the specific information, they are guaranteed to get exactly what has been approved by the corporate policies. They get an exact definition of what does it mean to be a customer, what does it mean to be a client. And they also had to minimize the ETL processing. They wanted to minimize the data movement. They wanted to leave some data where it currently resides. So again, data movement is not disappearing. Data movement is going to remain. But real-time data access with metadata management is critical to the data fabric. The last use case I would like to cover is very interesting because of its sheer value of data sources and applications. So Johannesburg Financial Services, the stock exchange, is another very interesting use case where they use Denodo for real-time and batch processing, end of the day clearance. And essentially what happens here is that, I know it's a little bit hard to see, but they connected the Denodo to 192 data sources. They created 1,700 metadata views on top of that. They use those 1,700 metadata views to create about 2,400 business views, 2,400 models on top of that for different use cases for different divisions. But at the end, they use those 2,400 to create 44 canonical models to be exposed externally. 194 data sources, down to 44 canonical models. Large data volumes, all done with real-time data access using data virtualization. And with that, I'm going to stop here and we can open for Q&A.
Thank you. Thank you very much, Inessa. A very clear explanation, and I always enjoy looking at the case studies. So we can now again dedicate some time to questions. So we should have a little less than 10 minutes. So again, please feel free to submit any further questions that you have. I see the chat here exploding. So we can probably go ahead with the first one. And I know we have quite a few questions left for Jacqueline as well. So hopefully we'll be able to get to those as well. So real-time data access, commonly associated with slower performance. How do you address this, Inessa?
So as Jacqueline also mentioned, data virtualization has been at play for decades now. So performance is no longer an issue. It has been an issue maybe, 5, 7 years ago still. But now all the optimization techniques such as push down, query optimizers, cost-based optimizers, use of MPP processing, doing branch printing. There are many techniques happening under the covers which ensure, as you saw as the Johannesburg Stock Exchange use case, can process large data volumes. So performance is no longer an issue.
Perfect. Thank you. So I'm just going to keep jumping to the next question. Implement centrally is a nice concept, but if the source system has already a security mechanism, then we have to work to re-implement such security in Denodo. What is your point of view on that?
So if you already have security implemented at the source level or maybe centrally in your corporate environment, you do not need to re-implement it. For instance, if you have access controls on a database level or the source in general, what Denodo can do, we can do pass-through, propagating the credentials, and such the actual security and access controls are going to remain at your source. We can also connect to your governance tools. We can use Active Directory. We can use single sign-on applications in your ecosystem to enable you to reuse as much of your existing infrastructure as possible while still taking advantage of the additional masking techniques and security features in the Denodo platform. So no, we do not want you to re-architect, re-implement your security model. We want to ensure that you can reuse as much as possible and we can enhance your user experience.
Perfect. Thank you. In the use case, you said Denodo has been used for data migration on the cloud. How does it work exactly?
So yes, since Denodo does support data movement, we can do data movement from the source to the remote table. You will use Denodo to create a definition for the remote table, let's say in Snowflake or Databricks or any other data source where we have write permissions. And then you can create a pipeline in the Denodo, which is going to move the data on request, or it can actually be a scheduled batch process. And for some data sources, such as Snowflake as an example, we also do bulk data movement, where we move the data without actually loading it into the Denodo platform. So yes, Denodo can be used for data movement to facilitate cloud migration use cases, and we have quite a few of them on our website.
Wonderful. Thank you. So Inessa, I'm going to give you a break. I'm going to take one of the questions we had earlier for Jacqueline, and that is one that says, how does the concept of an operational data store, oh, it disappeared, fit into this consideration? Jacqueline, this one's for you.
Okay, sorry. Thank you very much. Great question. So an operational data store, why would I build an operational data store? I build one because I basically want to have access to operational data in near time. So I don't want to wait a day until it's integrated into the data warehouse or a number of hours even. I want to have access to operational data near time. Not exactly real time, but near time. And I make a copy of the data basically for two reasons. Because one, my source system just cannot take the additional workload of sending queries to it, because the data model doesn't perform for analytical queries. So there are limitations in my actual source system that won't allow me to virtualize directly to there. That's one reason. That's why I would make a one-to-one copy and then optimize this copy for these ad hoc queries. And the other reason would be because I don't have history in my operational database. And maybe I do want to have some level of history available for these ad hoc near-time queries that I'm posting. So an operational data store would be just an additional building block that you could use in your overall virtual architecture. I hope that answers the question.
I hope so. Okay, let's take another one for Inessa. How can we manage control and data accessibility within data virtualization? Are users' authorizations granted based on the data source systems?
So there are many techniques to do that. No, it doesn't have to be data source specific. Essentially, what you do in the Denodo platform, you connect to your data sources. You create a metadata representation of those data sources, what we call base views. And then you start building the models on top of them. You create a semantics layer. So you can apply access controls, be that role-based access controls or attribute-based access controls at any level. So you can create a role saying that any user with a role of a data scientist can see any information marked as sensitive, but the sensitive information should be masked. And that sensitive information may actually be coming from multiple data sources. You can also, as I mentioned before, do data source specific access controls. But normally, what we see our clients do is do more of the global approach where I'm going to virtualize multiple data sources. I'm going to identify, let's say, multiple instances of phone number, email across multiple data sources, across multiple views. And then I'm going to create policies based on that semantic definition. Because if the user in essay is not allowed to see social security number from Oracle, most likely the user in essay should not see the social security coming from a SQL Server or Snowflake. So why would you want to create it on every single source system when you can create it once in a middle layer? Can you do both? Yes, you can, all depending on the use case.
Perfect. I'm afraid that we are running out of time. I wish we could get to all these other questions that we've gotten, but we might be disconnected. So I just want to thank everybody for joining today's webinar. I hope you enjoyed it. I want to thank both of our speakers for wonderful presentations. And any questions that we did not get to answer, we will do our best to get back to you via email. Have a wonderful day.